Okay, so here's a second example of a minimal surface, and this is called a gyroid, and it's a really interesting surface. I should have prepped a little bit more, but I think it was discovered in the 1980s, so fairly recently in terms of math things. And I 3D printed it yesterday. What do you think about this shape?
Well, the kind of shape to it looks like it's a cube, kind of altered cube.
Right. So it looks like you made these wavy lines on the faces, and then punched holes. Not sure. I can get the holes to show through.
Well, let's see. Why don't you? Here, I can tilt the viewfinder down for you a little bit if you want.
Just like that. Sort of. There, you can sort of see that the holes. So.
Right. Yeah, the camera, I can see them.
Mm-hmm.
Okay. So what can you tell me about the holes? How many sets of holes are there?
Let's do some. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, maybe? And then there's like some half holes.
Yeah, some ones that these aren't actually holes.
Yeah, that's just because the shape actually would go infinitely off in every direction, but
There
I didn't.
would be infinite many.
Yeah, when I tried to print that, it just said it was going to take too long.
Well,
Yeah.
so it looks like they're sort of in these hexagonal groupings. 1, 2, 3, 4, 5, 6. These 6 holes here make a hexagon.
Okay, well, what's special about those holes? Why would you group them together?
Well, they're sort of all right next to each other.
I'm gonna bring in an alternate shape. It's this shape, which we 3D printed a while ago, and it may be related. I'm not sure.
So
It sort of looks similar, but
the holes are kind of more in it.
they're sort of more uniform.
How many sets of holes? Not how many holes, but how many sets of holes would you say there are in this shape?
Well, so a set would be like this, like a hole this punched all the way through. So like these 2 holes here.
Okay, that's interesting.
So maybe.
What hole would that be similar to? What hole?
So it would be this hole, the hole that I'm pointing to.
Uh-huh.
And then if you flip it around, it would be similar to the one outlining.
Okay, what other holes would be similar to those 2 holes?
Well,
It would be the ones right next to them. It would be this pair.
Okay, so can you give me a name or a word for a property that those holes have?
Well, they're similar
But how would you describe them?
or congruent.
well, they're all the same. You could take this pair of holes and rotate it. We can rotate this sort of cube shape in different ways to make this hole become any of the other. This pair of holes become any of the other pairs of holes.
Oh, well, that's a very interesting observation.
So all these holes they're all similar to each other, and
By rotations?
yes.
Similar by rotation.
Okay, that's a great observation.
Let's see how many of them.
Sometimes rotations are called symmetries.
So they're symmetrical.
Well, there's some symmetries in this. So there are holes that go this way, but you would call that what, right to left? Going this way, where you're standing?
Yeah.
Yeah.
Yeah, okay. And how else, what other sets of holes would you say without rotating?
Well,
Down to, like, up to down. The bottom to the top.
What are you calling the bottom?
So this side here is the bottom, maybe.
this.
Okay.
So it goes up to the top. There's
All right, so there's some that go that way. I would have called that front to back,
Oh.
where you're standing.
And then there'd be the top to bottom,
yeah.
Top to bottom.
like that.
Yeah. Yeah,
So
interesting.
front to the back.
Okay. Cool. And now that we've studied this other shape, let's go back to our gyroid, okay?
Okay.